All right, folks, it's me again. We're gonna talk about Newton's second law real fast. Right, this is in some ways this is the really the most important one, at least in terms of math. This is the most important one. They're all very important. All right, so Newton's second law of motion, right, basically talks about the acceleration. Newton's first law basically says that an object does not accelerate unless there's an unbalanced force. Right, so now Newton's second law tells us what that acceleration is going to be based on that unbalanced force. So the acceleration is directly proportional to the net force, or the unbalanced force, and inversely proportional to the mass. So in other words, if I double the force, I double the acceleration. But if I double the mass, I'm going to cut the acceleration in half, which makes sense because the more mass something has, the harder it is to move. So in other words, the harder you push on an object, the more it accelerates. The heavier an object is, the more massive an object is, the harder you must push it in order to cause it to accelerate. All right, so here's our formula. Net force equals mass times acceleration, or F net equals ma. Sometimes you'll see it written as sigma F equals ma. The symbol, the Greek letter sigma stands for the sum of, or the net. All right, but this is the one that we'll write most of the time. But if you see that sigma, looks a little bit like an S, but kind of much more sharp. Right, that just means sum of, just like delta means change in math, right? The sigma means summing them all up, right? So here's our units, right? The unit for force is newtons, the unit for mass is kilograms, and the unit for acceleration is, of course, meters per second squared. And this is just kind of a demonstration. If I have I'm applying a force to a golf ball that has a really small mass, the acceleration is going to be quite large. But if I try to do the same thing to a truck, since the mass is really big, the acceleration is going to be really small. So let's do a couple of examples here. Suppose you apply the same amount of force to two carts. One cart with a mass of 4 kilograms and the other with a mass of 8 kilograms. Right? Which cart is going to have the greater acceleration? Same force, right? So F net equals ma, right? So if the forces are the same, right, they're not going to change. The one with the bigger mass, because now let's say that the force is just equal to 1, right? If the mass is equal to 4, then the acceleration would have to be equal to 1 over 4. And if the mass was equal to 8, the acceleration would have to be equal to 1 over 8. Well, which one is bigger, 1/4 or 1/8? Obviously, 1/4 is, so the 4 kilogram mass. The less mass, the more the acceleration. All right, how much will that acceleration be? Well, we can do, how much greater was that going to be? Well, the mass, 8 kilograms, is twice as much as 4. So the weight, the acceleration is going to be half as much, 1/2 times. All right, so if the net force remains the same and the mass triples, what happens to the acceleration? All right, so the easiest way for me to do any of these, I just write out the equation, net force equals mass times acceleration. Right? If the force stays the same, I'm going to put a 1 underneath it, because that means it's like multiplying by 1. It doesn't change, right? So if I triple the mass, what would I have to do to the acceleration in order to make this equation work? 1 is equal to 3 times what? And that would, of course, be 1/3. So the acceleration is going to change by 1/3 as much. Right? If the mass stays constant and the force triples, what happens to the acceleration? So we're going to write it out again. F net equals ma. This time the mass stays constant, right? And the force triples. So in order to make this equation work, what do you have to have? A would have to be 3 times as much. So A would change 3 times. Right, if I push a car with a net force of 40 newtons and the car's mass is 3,000 kilograms, what's the acceleration? Well, that's easy. Right, let's plug and chug. F net equals ma. So it's going to be 40 equals 3,000 times A. We divide both sides by 3,000. And I get my acceleration to be 40 divided by 3,000. It's going to be a really small number, 0.0133 meters per second squared. All right, so what if the net force is zero? If the net force is zero, that means the acceleration is zero. What does that mean? Okay, that means the object is at rest. It's not moving, right? So, well, if the object, I'm sorry, let's say that again. If the object is at rest, it means it's not moving, right? And it's not going to change. If the object is already moving, it's moving with constant velocity, right? The acceleration of zero doesn't mean that it's not moving. It just means it's not changing how it's moving. Okay, so again, if it's at rest, it's not moving. It's going to continue not moving. But if it's already moving, it's going to move with constant velocity. It's not going to change speed or direction. It's going to continue in a straight line. All right. So next I'll do our last video on Newton's third law, which I think most people are very familiar with.